All right, today we are continuing with derivatives. Yesterday we learned the basics. Today we're going to continue with those basics, but start applying them to different ways. This is the favorite thing for calculus exams to do. It's to take something you know and show you different ways of doing it and see if you can apply what you know. And that's kind of the theme of the day. All right, in bell work, pretty straightforward. Find f prime of x. We're just finding the derivative. The first thing I would do on something especially crazy like this is rewrite it. I am not doing calculus at first. Okay, technically what I'm doing first is algebra 2. One thing we didn't necessarily talk about yesterday is sometimes that throws students off. If you don't want to deal with fractions, just pull that 4 out in front. It is 1/4 x to the fourth. It might just make you make less mistakes. It's just a constant. 4 over x squared. I don't like 4 over x squared. Kendall, how could you rewrite 4 over x squared? Yep, 4x to the negative 2. Same thing here. I don't like that 4. I can make it 1/4 x squared. Just maybe make it one less thing you got to worry about. Minus, I don't like 8 over square root of x. Adam, how could I rewrite that? 8x to the negative 1/2. It's square rooted, so it's 1/2, and then it was on bottom, so it was negative. We could do that, and then it's minus 3x. Woo! That's really ugly. I made it extra long. They would never give you something this crazy. I'm just having you practice a whole bunch of derivatives and a single problem. Let's go through it. Chris, what would the derivative of 1/4 x to the fourth be?
4x to the third.
We multiply by 4, so what's my new leading coefficient going to be?
X to the third, sorry.
Good, x to the third. 4 times the fourth, that goes away. Then we've got x, and what's the derivative of x going to get us? 1. Thomas, what's the derivative of negative 2 going to get us? Nothing, because it's just a constant. So Thomas, what's the derivative of 4x to the negative 2?
Negative 8x.
Yeah. Yep, I'm just going to spread it out so we can keep constant. 8x over negative third. Cool. Then we're taking the derivative of the next thing. Ashley, what's the derivative of this going to be?
Negative 1/2 x.
Negative 1/2 x to the first power because she subtracted 1 there. And then we got our next part. Sean, what's the derivative of that going to be? 4x to the negative 3/2 because he's subtracting 1. Everybody, what's the derivative of negative 3x? Negative 3. That's my derivative. Ugly. It's big and long and nasty. It's fine. We could combine like terms if you wanted to because you have a negative 3 and a 1 here. But it's calculus, so you don't have to. Okay, unless it's a multiple choice question where you're trying to match up, don't combine like terms. Okay, there's a test that I give first semester to my regular calc kids, and the problem is 2 times 3. And every year I've given it, about 4 to 5 kids say 2 times 3 is 5. Your brain melts down when you're doing a whole bunch of other calculus. If you don't have to simplify, don't do it. It'll make your life easier. All right, so working through notes, we read this first one. It says, write the equation of the tangent line. So as soon as we read that phrase right there, what should we put on our paper? Y minus equals x minus, point slope form. Okay, where the x is going to go here, the y is going to go there, and the slope is going to go there. X, y, and slope. So what number can I plug in right away? My x value. We know that we are trying to write the equation for v of x at x equals 1. So right here we can just put the number 1, x minus 1. What would be the next easiest thing to find? The y value. So I'd take the 1, I would plug it in. Find v of 1. Go ahead and do that real quick. Then show me with your fingers what you got. Here we go. We're plugging in. So it is 1 squared plus 3 all over h of x. So h of x, oh, they had to tell me something. Right here it says h of 1 is 2. So for h of 1, I'm just plugging in 2. That's 1 plus 3, which would get me 4 all over 2, which gets me a y value of 2. V of 1 is 2. I wrote that down. That goes with my y. So I got my x and my y, because right now I have the ordered pair 1, 2. That goes with my x, that goes with my y. I still need the slope. How do I find the slope at a point? Derivative. That's what a derivative is. It's the slope at a point. Okay? So to find that, we have to take the derivative of this guy right here, of v of x. So if we are doing this, if this is a free response question on the AP exam, okay, a lot of my students will want to jump in to writing numbers. You don't want to do that. Okay? If they're asking you to find v of x, the first thing you should write on your paper is v prime of x. We want to write the equation of the derivative. Okay? If you just give me a numerical answer, even if it's right, it's going to be wrong because you have to show the work to get the derivative. You just have to show what that derivative was. What are we going to use to take the derivative of that v of x equation? It is quotient rule. We have two different things. We have an x on top and we have an x on bottom. If you have an x in the numerator and the denominator, we can use quotient rule to find that derivative. Let's try to do that. So quotient rule is low d high minus high d low all over low low. So let's talk through that. Okay, Kate, we're doing low d high. So what is low going to be for us? Just h of x. We're just writing it down. So low is h of x times d high. Kate, what about the derivative of d high here? 2, because I'm multiplying by 2 and I'm subtracting 1. So it's 2x. We still got that x there. So low d high, minus sign. High d low. So high here. Molly, what am I going to put for high? Wonderful. I like that she said parentheses. Since there's more than one thing, she has to put in parentheses. That would be a big mistake students make. Times, that's high. Now we're doing d low. Molly, what'd you put for d low? It's the derivative of h. And they didn't give us an equation. If they gave us an equation, that'd be easy. Actually, it's even easier here because the derivative of h for us is just h prime. That's all you need to write because that's the derivative of h. We don't know what that is, but we don't really care. We just write h prime because that's the derivative of the equation given. And it'll make more sense the more we do it. And then on bottom, it's low, low. So what's going to go on bottom? H of x squared. So I'm going to throw that all in parentheses and squared. That is my derivative. Now that I have found my derivative, all I have to do is plug in some numbers. Okay. Now my job is to find v prime at 2. So if I'm trying to find v prime at 2, the first thing it tells me to do is to find h of 2. What am I going to plug in for h of 2? Lucas? Oh, my bad. We're finding v prime at 1. My fault. I got distracted. V prime at 1. If I'm finding v prime at 1, how do I do that? Yeah, it tells us. It's right here. Okay, h of 1, it's right there. H of 1 is that's what I'm doing? Oh, it's 2. Times 2 times my x value. Well, my x value is 1. Keep going. Try to simplify that down. See what you get. Go. All right, let's look. There's a lot of different things you could make mistakes on. Be careful when you plug in. It's minus 1 squared plus 3 times h prime at 1. Oh, that's 4. All over h of 1. So that's 2 squared. Then we're going to simplify. 2 times 2 times 1. That is 4. Minus 1 squared plus 3. That's 4 times another 4. That's going to get me 16. All over 4. If I were to simplify, that's 4 minus 16 is negative 12 divided by 4. My derivative is negative 3. That is the slope at the point. It is negative 3. That's what goes right there. That is the equation of the tangent line. It's just algebra 2. We didn't do anything hard in that. It's algebra 1, it's algebra 2. But it's simple places that you can make mistakes. That's why we practice. The other thing I would say is if you don't have to simplify, don't do it. You're going to make mistakes. That was just multiplying and subtracting, but you guys are really smart and still made mistakes. If you don't have to simplify, don't do it. That time I asked you to, but you don't have to all the time. Questions there? All right, let's look at this next section. So another thing they love to do is give us tables. Okay, that's kind of what we just did. They gave us a table. They told me some numbers. But use the chart to find the derivative at x equals 3. Okay, I'm finding the derivative. So they gave me f of x. Eventually, my goal is to find f prime at 3, to find the derivative at 3. Before I just jump into finding f prime at 3, the first thing I want to do is find the derivative of the function. I want to write down what f prime of x is. Otherwise, you won't get your points on this. So you want to write the derivative first. That leads us to this first one. So we're going through, it's adding and subtracting. So I want to take the derivative of each thing. So take the derivative of that, the derivative of that, and the derivative of that separately. This first one we've had some discussion with. What is the derivative of 4g of x going to be? It is 4g prime. That's it. Anybody want to do something different there? Okay, 4, since it's a constant, just is going to remain and we take the derivative. A lot of students will ask me, well, why didn't we use quotient or product rule there? You could have. If you use product rule, this is the first, this is the second. So it'd be first times the derivative of the second plus the second times the derivative of the first. What's the derivative of 4 going to get me? 0. So that cancels. Oh, it's just that. All right. If you have a constant, it's just the constant times the derivative of the other thing. That's all you have to do there. That's all we need. Okay. So for this same idea, what is negative 1/2 h of x going to get me when I take the derivative? Negative 1/2 h prime. Cool. And what's the derivative of 1? 0. Done. Okay. Now all I need to do, that's f prime. Now I'm trying to find f prime at 3. So if I'm finding f prime at 3, I'm taking the number 3 and I am plugging it in. So this is going to be 4 times g prime at 3. This table's pretty easy. I'm just looking at the table. G prime at 3. Oh, it's negative 2. Minus 1/2 times h prime at 3. H prime at 3. Oh, that's negative 1. And then you put a box around it, because the chances of you making a mistake there are pretty high. This is the answer. If it's free response like this, that's a perfectly legitimate answer. Now, most of the time, if it were a question like this, it would be multiple choice, so you'd have to figure it out. That'd be negative 8 plus 1/2. It'd be negative 8.5 or negative 7.5. See, I did the math wrong, and I'm a math teacher. It's going to happen. Okay? Try to avoid it if you can. Questions on that? Number 8. Number 9, same thing. We're using the chart to find the derivative at x equals 3. So eventually I want to find, oh my gosh, that's the ugliest s of all time, s prime of x. Eventually I want to find s prime at 3. But in order to find s prime at 3, the first thing you got to do is find s prime of x. Go ahead and try to do that. Specifically, what rule do we need here to find s prime? We need product rule. Do it. We're finding product rule because we have two separate functions being multiplied together. So if I'm doing product rule, JC, what's my derivative going to be here? I'll help you through it. It's first. So what am I going to write first? G of x times the derivative of the second. So what's that going to be? H prime of x plus the second times the derivative of the first. Boom, there we go. That's my answer. Okay, that's my derivative. I need to write that down first. Once I've written that down, now I'm finding s prime at 3. So if I'm finding s prime at 3, I'm doing each of these at the number 3. You could write it out. This one I feel like confident enough to jump to it. So it's g of 3 is 4 times h prime at 3 is negative 1 plus h at 3 is 3. G prime is negative 2. We win. If we were to simplify, what would we have gotten? Oh my gosh. Negative 10. Make sense of what we're doing? Again, leave it right there. You get full credit. Let's try one more. There is one more like this. W of x, g of x minus h of x all over g of x. Eventually, our job is to find w prime at 3. But first thing I need to do is find w prime of x. What rule are we going to use here to find the derivative? Quotient. Be careful with parentheses here. Go. As we work through this, we're finding the derivative. So we decided we need quotient rule because there's a function on top and a function in the denominator that are being divided. So we're going to use quotient rule. Okay. So if we do quotient rule, that's low D high minus high D low all over low low. So Maddie, what am I going to put if I'm saying low first? G of x. Good. And then it's D high. So G of x times what then?
G prime minus
G prime of x minus h prime of x. And again, since there's two things, it's really important that you throw those both inside of parentheses because it's times that whole derivative. That's important. Okay, so we got that. I got to move that out of the way. That's low D high minus. Now I'm doing high D low. So if I'm doing high D low here, Ashley, what's high going to be?
G of x minus h of x.
And again, we've got more than one thing. Throw it in parentheses times D low. So what's D low going to look like?
G prime.
Yes, ma'am. Good. And then it's all over low, low. So that is g of x all squared. Everybody with me to that point? It's long. It's weird, but it's not terribly difficult once you've done it a few times. You might not be great yet. All right, so now we are going to do w prime at 3. So all I'm doing is I'm using my table up here and plugging in. So g of 3 is 4 times g prime minus h prime, so it's minus a negative, minus g at 3 is 4 minus h is 3, negative 2. And on bottom, it's g of x squared, so it'd be 4 squared. There's a lot of things that you could make a mistake on there. Okay, if we can leave it like that, we could. If we wanted to simplify, that'd be 4 times negative 2 plus 2 all over 4 squared. That'd be negative 6 over 16. Negative 3/8. Somebody agree with me on that? All right. Oh, yeah. Oh, no. See? Again, don't do stuff. That's going to be 2. Negative 1/8. There we go. I agree with that. Again, it's something you got to be good at, but when you have a lot of numbers, if you leave it, you're better off. Questions there? One more type here. The other type of problem that they love to do is this one. Okay, they love to give us graphs. And again, we're going to be able to see all of this, and we'll practice it a lot the rest of the chapter. Okay, we still got a lot of time to review, but this is something they love to do. Below, they gave us a graph of f of x and g of x. F of x is this red line. G of x is the black one. Given that k of x equals f times g, our job is to find k prime at 3. So what do you think we need to find first? Find the derivative. Find k prime of x. Write it down. Go. So we're going to start off by finding the derivative. What rule do we need here to take the derivative? Product rule. Thomas, talk me through product rule here. Yep, so g prime, good. Plus the second. The derivative of the first, f prime of x. Good. That's his derivative. You're going to score 1 point just writing that down. Okay, writing down product rule is going to score you a point. But now it's saying, all right, we don't want just that, but we want to find k prime at 3. And it's easy when they gave me a table because I just got to find the numbers. Here it's a little bit tougher. Okay, right here I want to find f of 3 times g prime at 3 plus g at 3 times f prime at 3. You don't have to write this down. I'm just doing it so it's easier to understand what we're doing. Okay, so if I want to find k prime at 3, I'm going to start off by finding f of 3. So here's my graph. Here's f. It's the red line. Here is 3. What am I looking for on that graph if I want to find f of 3? A point. Show me with your fingers. What is f of 3 going to be? F of 3 is 2 because it's just asking me for a point. Then it's g prime at 3. So again, here's 3. This is g prime right there. Or I'm sorry, that's g. What am I looking for on a g graph to talk about g prime? Slope. Show me with your finger. What is g prime at 3 going to be? G prime at 3 is negative 1 because I'm going down 1, over 1, down 1, over 1. That whole line is just a slope of negative 1. So this is negative 1 plus g of 3. Show me with your fingers. What do you have for g of 3? We're doing g of 3 again, so it's a value right there. The value is 1, and then f prime at 3. Show me with your fingers. What's f prime at 3? That would be negative 2, because again, we're doing the slope. We're going down 2 over 1, down 2 over 1. That slope is negative 2. We leave it. We walk away. It's technically negative 4, but don't simplify if we don't have to. Questions there? Doing okay? All right, flip it over to the back side. We're going to skip number 12. It's fine. We already kind of did it in the first one we did. Okay, looking at number 13. 13 and 14, there's one question each about each of these, but they're both really, really important. Okay, the good news is we will continue to do this, all of calculus, but both of these concepts are really important and will happen a lot. Okay, the first one says, determine where on the graph of the function has a horizontal tangent. Where on the graph of the function has a horizontal tangent? Show me with your arm, what does horizontal look like? Horizontal is a flat line like this. If I'm asking you for the tangent of that horizontal, what does that mean? You're not wrong. It is a relative max or min, but if I'm asking for the tangent line, I'm talking about its what? Slope. What is the slope of a horizontal flat line? 0. So this fancy language here, determine where on the function has a horizontal tangent, just means determine where on the graph the slope is 0. That is what it's describing. That's all it means. Determine where the slope is 0. They gave me a function. What do I want to do with that function to find out about its slope? Find the derivative. Great, I'm going to find the derivative. I want to know when the slope is 0. So what am I going to do to figure out when that slope is 0? Am I plugging in 0? Set it equal to 0, because I want to know when the slope is 0. That means set it equal to 0. Do it. Find an answer. We want to know when the slope is 0. So the first thing I got to do is find the slope. Okay, so we're going to find the derivative first. Sean, what's my derivative going to look like here? Minus 4x. Good. 4x cubed minus 4x. We found the derivative. We want to know when it is 0. When you see that word is, that means equal to. I want to know when it's equal to 0. So I need to solve that. I'm now done with the calculus. This is now an algebra 2 problem or something we would have done back in September. If I want to solve that, I need to factor. So what do both these things have in common? You take a 4x out, you're left with x squared minus 1. You set that equal to 0, you get 0. You set that equal to 0, you get x squared is 1, so x is equal to plus or minus 1. So there are 3 different places on that graph where the slope is 0. All right, and this is what that looks like. Okay, we graphed this thing right here. Where is the slope 0? You guys already kind of said it. It's happening at maximums and minimums. Boom, 1, 2, 3, negative 1, 0, and 1. That's what we just described. Okay, we were able to find where the maximum minimums happened with just a derivative. Make sense? Last thing. Okay, this last thing looks big and fancy. It's not too bad. Higher order derivatives. Okay, right now we know how to find the first derivative. The first derivative will tell us slope. Okay, but we can continue to find more derivatives at that point. All right, if we take the first derivative and continue to find the derivative of that, we could find the second derivative of a function. The second derivative of a function, 90% of the time we will write it like that, f double prime. Okay, about 10% of the time we'll use that terminology right there, d squared y over dx squared. You see the dy dx and there's a 2 with it. It's the second derivative. All right. We could keep going from there. We could find the third derivative. The third derivative, we could use f triple prime, okay, or d cubed y over dx cubed. It's the third derivative. And all of Calc AB, I would guess that we find the third derivative like twice. It is not something we do very often. We'll find the second derivative a ton. Third derivative, not really. Okay, so don't worry about it too much. You could also find the nth derivative as a function, and they would write it like that. My students are doing a mock exam, a practice test next week, and on one of their questions, they have to find the 37th derivative of something, which seems big and scary. That means there's a pattern going on if that were to happen. But we could do it. It's not real hard, though. Okay? Don't let it seem more difficult than it is. And again, most of the time, we'll find the first or second derivative. Let's find some derivatives. We start off with this guy right here. This is y. First thing it asks me to do is find y prime. Lily, what would my first derivative look like? Yep, 12x cubed minus 16x. We just found the derivative. And to find the second derivative, all you got to do is find the first derivative and then find the derivative of that. So, Sam, what would my second derivative look like? 36x squared minus 16. Cool. We found the second derivative. To find the third derivative, we just got to take the derivative of that. So, Lucas, what would my derivative look like there?
72x.
Yep, 72x. And to find the fourth derivative, all we would have to do is take the derivative of that. What would the derivative of 72x be? 72. And if I want to find the fifth derivative, we would just take the derivative of that. What's the derivative of 72 going to get you? 0. And if I want to find the sixth derivative, all I have to do is find the derivative of that. What's the derivative of 0? 0. If I wanted to find the 109th derivative, what do you think the 109th derivative would be here? It'd still be 0. It wouldn't be that easy if they were to ask, but we could. Okay, it's not a real complicated process. To find higher order derivatives, you just find a derivative of the one before it. You just keep finding derivatives down the line. Questions on something we did today?